Hello and good day everyone. Welcome to my YouTube channel, and for today's video, we will learn how to implement stacks using linked list. So I have an example code here, and the output for that is this. So how we come up with this output? So we will discuss the code one by one. So as we know that our program will start reading from our Java main method. Next, it will read the instantiation or object creation of stack as linked list or named as SLL. So this will trigger the public class stack as linked list. And also it will read these methods. However, it will perform if called, if tawagon ra. So now let's focus for this group of code. And by the way, I forgot, this code, the purpose of this code, this is a method that will check if the stack is empty. And for this method, the public void push, so this method is for the insertion of stacks. I mean the insertion of data in the stacks. And for this method, public int pop, it will perform the deletion of data in stacks. And lastly, the public int pick is for displaying the current value of the stacks. So let's focus in this group of code. So this group of code will kanang create a new node. So public class stack as linked list. So it will declare the stack node root variable. And next we'll read the static class stack node. And under it we have the declaration of integer variable data and the declaration of stack node next. And also we have the constructor. Under it is that this data is equal to data. So note, our root is automatically equal to 0. And this data is equal to 0. So why? Because this data, since our parameter here is no value, so automatically if magpass siya og value dire sa atong constructor, so since no value man, so automatic our data is 0. So that is why this data is equal to 0. So for the illustration of our stack, so 0, so for first stack is 0 or null, so empty. And that is our root. So next it will read the SLL.push with a parameter value of 10. So this means that it will call the object creation or the instantiation and will access to the push method. So here we can now access our methods in our class stack as linked list. So first we have our instantiation or object creation of stack node and named as new node. So this will trigger this group of code since gitawag man siya, so it will declare the integer variable data, and it will also declare the stack node next and with the constructor. Then under it is this dot data equals data. So we need to check if root is equal to null. So as we know that our root is equal to 0. So 0 is equal to null. So it is true. So we need to perform the code below the if statement. So the statement is root is equal to new node. So as you can see, it will call the object creation new node. So we will back to this code. So And again, we declare the integer variable data, stack node next, and constructor. Then under it is this dot data is equal to data. So we have note here, this dot data is equal to 10 and root is equal to 10. So why our root and this dot data is 10? So ngano atong root kay na value nga 10? It is because our parameter here, the value is 10. So we need to pass that parameter here. So the value of data now is 10. So it will also pass to our constructor. So our value of data here is 10. So that is why this dot data is equal to 10 and our root here is 10. So our stack or our node now, we have value 10. So next, we need to system that out that println data plus push to stack. So we know that our data value is 10. So the output would be 10 push to stack. So next code, we have SLL.push with a parameter value of 20. So once again, it will call the stack as linked list SLL and will trigger and we access the public void push method. And again, it will read the code, the object creation, and this group of code will be triggered. And next, we will check if root is equal to null. So since our root now have a value of 10, so 10 is equal to null is false. So that means we need to jump to the else statement. And let's perform the statements under the else. First, we have stack node temp is equal to root. So that means we know that our root is equal to 10, so stack node temp is equal to root. And our root is 10, so that is why stack node temp is equal to 10. Next, we have root is equal to new node. So as you can see, it will call the object creation stack node new node. So this group of code will perform. So declaration of integer data variable, the declaration of stack node next, then the constructor. So and this dot data is equal to data. So note, our root before is equal to 10 and stack node temp is equal to 10 and this dot data is equal to 20 and root is equal to 20, which is our new value. So why? Because once again, our parameter here, the parameter value here is 20. So we need to pass that value to the method and to our, and also it will the 20 will also be passed to our constructor. So that is why this dot data is equal to 20. So we added new node because of this group of code. So this group of code will create a new node. So we assign our root now is 20 and our stack node temp is 10. So next, new node that next is equal to temp and that will point to the 10. So the new node dot next is equal to 10 will point to the 10. So system.out_print, so that would be 20 push to stack since our data value is 20. And next was again the same process, sll.push with parameter value of 30. So we call the stack as linked list SLL and will trigger the method push. So we need to to pass the value of our parameter to the method. And next we'll read the object creation stack node new node, and once again it will trigger this group of code and check if root is equal to null. So our root now is 20. So 20 is equal to null is false, so we need to jump to else. So in else we need to perform the code under it. We have stack node temp is equal to root, and our root is 20, so that is why stack node temp is equal to 20. Next we have root new node, so again it will call the object creation or the instantiation stack node new node, and will trigger this code to make a node, a new node. So once again, int data stack node next, and the constructor will also have, so the constructor will also have the value of the data, which is 30. So because we pass it, and the value of the parameter will also pass to the constructor. So this dot data is equal to 30 since data is equal to 30. So for the illustration, so our root now is 30. So before, our root is 20. So our root now is 30. So next is new node dot next is equal to temp. So this will point the root to the temp. Next, it will system out dot print. So that would be 30 push to stack. And next we have system out dot print ln, then sll dot pop. So we have our new method pop. So it will also call the object creation stack as linked list SLL, then it will access to the public int pop method. So under it, we have the declaration of, initialization of integer variable pop with a value of integer that mean value. So we need to check if root is equal to null. So if root is equal to null, so that means stack is empty. So since our root now have a value of 30, so 30 is equal to null is false. So we need to jump to else. So we perform the code under the else statement. We have pop is equal to root data. So that means our data, the data, which is the 30, will be pop. So pop means pop means to delete. And next we have root is equal to root dot next. So that is root is equal to 20. So why 20? So our root is now 20. It is because gipop na to ang atong root dot data, which is the 30. So the illustration before, so we pop this, so that is why our root now is 20, and it will return pop and print, so that would be 30 pop from the stack. Next is system.out print top element is sll.pick. So we have our new method. We'll call the new method. So SLL will that pick, so it will call the object creation stack as linked list SLL, and we will access to the public.intPick method. So we need to check if root is equal to null. So since root is equal to 20, so 20 is equal to null is false. So we need to jump to else, then return that root data. So remember, our root data is 20. So that would be top element is 20. So which is correct because our root is 20. And that ends our topic. And I hope you learn, and thank you and have a nice day.